today our talk will be on the importance of science communication and accessibility in some practical ways that we as scientists and individuals can communicate with the general public. So I'll speak for about 10-ish minutes and then I'll hand it over to Rebekah. So I want to start off really broadly and probably really, with a lot of relevance. I want to talk about misinformation. So since the declaration of COVID-19 as a health emergency, public concerns about misinformation overall have been on the rise. So you can see on this graph the frequency of Google searches of misinformation since Trump's inauguration. And after the declaration of a health emergency, searches for misinformation have generally just been quite on the rise in comparison to previous years. And this misinformation is incredibly prevalent even now. So the World Health Organization has a webpage dedicated to debunking myths about COVID-19 that include myths about transmission. So the idea is that 5G networks or houseflies or even swimming in a pool can promote transmission, and about prevention. So thinking that eating peppers or drinking alcohol or exposing yourself to the sun or cold weather can help prevent your contraction of COVID-19. So what's clear is that this misinformation is not beneficial to society. It only really creates confusion and requires debunking. So in order to combat misinformation, we need to take stock in our role as scientists and our role in our relationship to the public. And I want you to consider this. So this graph is from the US Census in 2019. So about 50% of the labor force has a high school degree or equivalent, meaning they have some knowledge about scientific concepts. But when you think about the science you learned in high school versus the science that you learn in college, it's really several degrees different, right? There's a variety of dimensions in which these differences arise in terms of complexity, depthness, the different types of courses you took. So it's essential that we consider and acknowledge the fact that the public, the general public, has varying levels of scientific knowledge. And thus, this sort of creates a division between scientists and the general public, whereby it creates a division of labor. So the public has to rely on scientists to understand complex topics like anatomy and further our understanding overall as a society. Because of this division of labor, scientists become specialists, and thus there are gaps in understanding. And these gaps are ever widening because of the complexity of science. Science has become more and more abstract and tied to artifacts like mathematical models or technological tools like MRI or microscopes that have, complex systems that aren't readily understood by general lay people. And if you can understand the tool, if you have to understand the tool to understand an outcome, that creates another gap in understanding, whereby it creates two steps in order to fully understand some complex concept. And this is especially important because a lot of scientific phenomena defies firsthand experience, like seeing oxygen or electrons or genes. And many topics that are of interest to the public, like climate change or nuclear energy or even stem cells, cannot be fully understood without deep scientific knowledge. So the public overall possesses a bounded understanding of science and related topics, so they have to rely and trust in scientists. But the erosion of trust is truly detrimental and has significant outcomes for society. So take the pandemic, right? In a recent paper, researchers found that how much participants trusted science affected their compliance with COVID guidelines, like washing their hands or just treating COVID as a risk overall. And this makes sense, right? If you don't trust the science, you don't need to comply with these guidelines. And so what you can take from this is just that scientists need to maintain their trust with the public. And I want to talk about how we might go about doing that, both as individually and as a collective of scientists. And I think one way that we can think about a solution to this is that science and the public should be a symbiotic relationship or some sort of mutualism, where we both as scientists and the public want to benefit from our relationship. We want to have the people be curious and invested in our work, but we also want to utilize them to utilize our findings in the best way to benefit society. So we want them to take our research and apply it to many different domains, like policy, for example. But we also want the public to continue. We also want the public to need us to continue to do our science and answer interesting and relevant questions in the best way that we can. So one way that we can think about this solution is sort of like a citizen-scientist collaboration, and I'll explain what I mean. So under this model of collaboration, we can establish a few guidelines to help promote the relationship between science and the public. So instead of investing time in relaying information that serves our own goals of communication, we should do our best to answer the public's questions that favor their comprehension and their curiosity. By trying to serve other non-related goals, we may only serve to increase panic, reactions, or confusion. And we would also want to explain our processes in a robust and understandable way. So we want to balance the exchange of information with the needs and engagement of citizens. This includes information like how are the findings obtained, or are the findings true or reliable from a probabilistic point of view. So if we emphasize that citizens need to understand the findings of our results, we can circumvent issues of science and trust. So if the findings are understood, science doesn't need to be reliant on trust or faith because the public will create their own informed interpretations, and that trust will follow after. And so to this end, Princeton's Insights mission is to make science accessible. We aim to meet the curiosities of both academics and the general public by reviewing interesting articles and provide them a resource of science that's accessible to them. And critically, these reviews come in short, digestible formats with minimal jargon and necessary explanations, so the information is widely available to people. And I think as a more practical explanation, I want to explain how we go about making science accessible in our organization. So this is our pipeline. So in our first step, we established a database of interesting recent articles. So these are articles that come from like 2019, 2020 to the present. And it includes a range of different fields and domains in STEM. This and comes from different groups in psychology, geophysics, and all the way to theoretical math. And we secondly have writers sign up to review different articles and submit drafts. And this is important, that the fact that we don't require certain articles to be written over others, so there's no bias. We allow writers to write about whatever they're interested in, whether that be within their field or outside their field. So someone in psychology can write about neuroscience or biology or chemistry, given the ability to write faithfully to the topic. And this allows for a broad range of articles to be available and accessible to the audience. So after receiving a submission, this is where the hard part comes in. So we have 2 editors on our team edit for content and readability. And this ensures that while maintaining the accessibility and understanding of someone outside the field, we want to make sure that the information is accurate and not misleading. So there are 3 ways we try to improve the comprehension of the review: by reducing the amount of field-specific jargon there is, and making sure to explain complex concepts that might be common knowledge for an expert in that field. So for example, in psychology, neural networks are something that are pretty commonplace. And so we would provide maybe like a 3-sentence explanation of what neural networks are. And finally, we require that our writers include a graphical abstract, so an image that explains the broad themes or results of a study. And this helps to pique the interest of our audience. It's much easier to view an image rather than quickly read a dense paragraph. In another essential step, we send out our final draft of the review to the authors before we publish. This gives us both another content check to make sure that everything we talked about is accurate, and in this step, give the authors the chance to respond to some interview questions, like what was the hardest part of the study, or what were the next steps that you feel are important. And we felt like this step is critical because we want to humanize science. So we want our readers to understand that these scientists aren't inaccessible geniuses, like not everyone's an Albert Einstein. They're normal people doing a job that they enjoy. And there are steps to this. And finally, we publish, right? This is a really exciting part. We get to show our work to an engaged and interesting audience. And we're constantly trying to increase our engagement with our audience using new plans, new platforms, and Rebekah will explain how we do this. And with that, I'll hand it over to Rebekah. I will stop sharing.
Cool.
Stop share, yes.
All right, thanks, Crystal, and thank you so much, Hannah and Penelope, for the wonderful introduction and opportunity to talk to everyone about Princeton Insights and science communication. All right, so Can you see my screen well? Everything awesome. So I'm going to be taking us through the idea of who gets to be a scientist and what that looks like for gaining the trust from and showing up for the general public. So first, I think it's an important idea for us to be able to convey the idea of who gets to be a scientist. Because when, like Crystal was explaining, when people are wondering and kind of questioning their trust in scientists, dispelling this belief that scientists are super smart people who always get everything right, dispelling that myth is going to be very important for moving forward. And so the answer to who gets to be a scientist, I would say, is anyone. We usually think of Albert Einstein or someone mixing chemicals, but the truth is that a scientist is anyone who follows a certain scientific process that I'll talk about in a moment. And so when we're dispelling this false belief, we need to be able to communicate properly that we are just people who have a lot of curiosity and have been able to master this type of process. And so, all that science is, and something that we need to convey, I would say, is that science is a process where you define a question, you perform an experiment, and you draw a conclusion. And Albert Einstein said that if you can't explain something simply, you don't know it well enough. So even though he was one of the greatest scientists ever, he also understood that being a scientist comes with responsibility. And that's something that I'll talk about in a moment. And so we have to explain that this process, the scientific process of defining a question, performing an experiment, and drawing a conclusion is something that people encounter every day. Like Crystal was talking about before, people in the United States, a lot of people only have a high school degree, but they do encounter the scientific process every day. Like, for example, um, people ask the question, hey, what would happen if I ate this packet of sugar? And that's a question. And then they could try it out and perform an experiment and eat the packet of sugar. And then they could make a conclusion. Oh, wow, I got really hyper. Or wow, I got really sick. So understanding and conveying that you encounter this process every day, but a scientist is just someone who has mastered this process on a more complex level, I think helps to dispel the false belief that there's a huge gap. And so I think that to understand and to begin to get into more complex ideas, all you need is curiosity. So that's one reason why I got into science. And I think that something that I try to convey whenever I'm doing science communication or talking to someone who's not a scientist, being just like, yeah, I'm just really interested in this topic or this question. And I may not be what someone typically thinks of when they think of a scientist. And so, speaking of thinking of people differently, how we approach diversity in science is super important. So the definition of diversity is differing from one another or composed of distinct and unlike elements or qualities. And so I think a lot of times when we think of diversity, we think of racial diversity. But what we need to be more concerned about is the diversity of thought and experience. You can have someone from a certain race, um, or like when people say, oh, we need to increase diversity, so let's like have a certain number of African Americans in the room. But it's like just having that doesn't ensure diversity of thought and experience. So yes, you may have an African American in the room, but they could be from the inner city in Chicago, they could be from the suburbs in South Carolina, they could be from the fourth richest family in Texas. So like making sure that you are including people with different thoughts and different experiences is the most important thing. And so then this leads to the point of respect of those experiences when we see others with different cultures and not just cultures in terms of like country cultures, like for example, I was born in America, but both my parents were born in Jamaica. But cultures in the holistic sense of the word, and the environments that people grew up in, and the different thoughts that they came from. And when we respect those people, we're able to gain so much, especially in terms of how we approach the scientific process. So when we're more concerned with gathering different thoughts and different experiences, we're more likely to perform better in our scientific process because we're going to have different people weighing in on our question and different people weighing in on how we perform our experiments. And then that's going to lead us to more cohesive and more thorough conclusions. And so, what does that mean? I think that it means that we should be seeking out and getting to know people who are unlike ourselves. And I would encourage us to not just aim for getting to know people who are like a little bit different from us, but really people who have vastly different experiences, because we're going to have better science and therefore better conclusions when we get to know people who are unlike ourselves. And so when we're thinking of and including many different types of other people in our processes, then we're able to better serve our communities. So, going off of a lot of points made by Crystal, when we've mastered the scientific process through our training and through including others, I believe we have a responsibility to our communities to share our findings with them. So, one question we definitely wanted to talk about and answer during our talk is how to engage the general public with our science. And I would say that the answer to this question is to engage the general public. And there are lots of different ways that we can do it. And I'll just highlight 3 ways, but this is by no means an exhaustive list. So, one way is to participate in outreach events. And I think that a lot of times when we're talking to high school students or um, undergraduates and freshmen and sophomores especially about being a scientist, then we can dispel this myth that scientists are only Albert Einstein or Marie Curie or all these people who lived in the past. But we can really get people excited that science is happening now, and understanding and feeding into your own curiosity is such an exciting thing, and that people can really start to look into this process as a career if that's something that they want, and make science seem less of something that's far off and unattainable. Another way is that we can offer to give a talk at libraries or museums, or Princeton has so many opportunities for us as maturing and matured scientists to give talks and practice minimalizing our jargon and making our findings accessible to the public so that we can gain their trust and bridge that gap. Another way is to just take the time to engage with our friends and our family. I know my family, they're always wondering, oh, hey, like, what are you doing? And so I'll explain it, and then they'll be like, but what does that really mean? And then instead of being like, oh, well, it's like all this different stuff, but taking to mind that quote by Albert Einstein, I want to know my work so well so that I can explain it to my older sister or my mom or my dad. And so then that will gain their trust in science as a whole, and people who have worked really hard to master this process and therefore combat misinformation because of their trust in science. So, when we're thinking of just normalizing scientific presence and trust in the scientific process, I think ways to do that is, or a big way to do that is to increase our scientific presence. So here are 3 ways, again, not an exhaustive list, to increase your scientific presence. The first is Twitter. I think Twitter is such a huge and amazing tool for scientists and science communication. Twitter is just buzzing with scientists in their everyday lives. And as you can see, Science News, the journal Science, they have their own Twitter where they highlight new articles, where they talk about their events and everything. Nature also has this. And Crystal and I have our own Twitters where we are able to share not only our work and our favorite articles that are coming out, but also the wins and woes of being a grad student, and just ways that we can make this whole process more accessible for people to understand that scientists aren't just like super old people, but that it's just exciting and that things are happening now. Another way is to listen and share podcasts. Princeton Insights, we just started a podcast called Princeton Insights, the highlights, and listening to that, sharing it with people is a great way to start to get accessible science to the general public. Science Weekly by The Guardian is another one, or PNAS also has science sessions amongst countless other science podcasts. And also in line with the mission of Princeton Insights, which I'll talk about more about how I engage through that medium, just sharing articles that you find interesting and just getting people excited about the cool science that's happening and having it be in a digestible format, I think is super cool and great for people to start to engage with it. So the pipeline for Princeton Insights as a writer, this is how I approach this medium of science communication. So the first thing I do is I identify an article which I find to be interesting and something that I feel like I could get excited about. Because when I'm writing about something that I find interesting, I think that the excitement as a writer can just shine through that paper. And then I write with the audience in mind, especially in the ways that Crystal was talking about. With the help of the editors, I'm able to minimize the jargon and create my graphical abstract in a way that's going to make sense for people and really be thinking about how can I best explain a complex concept, tongue twister, in a way that people are going to understand and want to engage with. Then we send out our final draft for the authors to get their opinion on it, because as Crystal is saying, we want to make sure that we're still staying true to the original idea and the findings of that article. And then we publish and we promote. And so we promote through Twitter, we promote through sending it to our friends and families. There is a newsletter where you can get monthly updates about the coolest articles that people have been writing for Princeton Insights, as well as the podcast that I've mentioned. So these are all the different ways that you can engage the public with your science. And you don't have to be a part of Princeton Insights to do this. I think that in just general everyday conversations, we can practice science communication and what that means. So here are a couple examples of how I visualize concepts and ideas. I usually try to use real life or nearby examples or things that are close to home for people to be able to understand the concepts that I'm explaining. I also try to periodically check in for understanding. I think a lot of times I can get excited about what I'm talking about and then I can go off on some long explanation, but I think that stopping and asking whoever you're speaking with to give you some feedback about your level of explanation and the jargon that you're using is going to foster a better communication and gain that trust of whoever you're speaking with. And then I always try to use the format of telling someone what you're going to tell them and then explaining that thing to them and then concluding by telling them what you just told them. So in conclusion, we talked about how we try to make science accessible. And I think that in sum, it's just remembering that we are those who are doing the science and that they are those who we do the science for. And remembering that and engaging with that mindset as we go forward and share our science with people is really important, and making sure that it's relevant to them and it's accessible for understanding. Thank you so much.
Thank you so much,